Okay, I want to introduce you to a few trig functions here, trigonometric functions. These are sine, cosine, and tangent, right? These are the only ones we're really going to deal with here. There are three more that you'll study a bit more in the next class. So in order to really talk about what these are, we need to look at a circle, specifically the unit circle, which means that this circle here has radius 1. What are sine and cosine? Well, if we pick any point on this circle, so let's say we take this point right here. We're going to draw a line from the origin to that point, and let's say we have an angle theta here. Okay? Then this point, the x value here is cosine theta, and the y value is sine theta. Right? So once we have that information, we know that this green length here, this radius, is length 1. So once we know that, given different angles, we can find the values of these. So let's make a chart real quick of a few common ones. Oops. Right, so some common values for theta, sine theta, cosine theta. Right. So some common things here. We have an angle of 0, an angle of pi over 6, right? An angle of pi over 4, an angle of pi over 3, and finally an angle of pi over 2. Right? If you know just these 5, you'll be able to get any of the other ones pretty easily. Right? Now let me also add tangent to this list, and we'll talk in a second about what tangent is. Right, so tangent. So let's learn how to fill these in. Actually, let me tell you one other thing, just in case you're wondering. So these are in radians. In degrees, this is 0 degrees, 30 degrees, 45, 60, and 90. Okay? So again, if you know just these 5, you're good to go. So how can we figure out the values here? Well, first what I'm going to do here is I'm going to actually copy this table. I'm going to fill it in a different way in a second here. So here, how do we do this? Well, what we can do is just for sine here, we're going to start with 0, 1, 2, 3, 4. Okay? And then we're going to square root every single one of these. Okay? And then divide them all by 2. Now you might be wondering, oh, but square root of 1, that's just 1. Square root of 4, that's just 2. Yeah, it is. And that's what we're actually going to do down here. Right? Square root of 0 is 0. 0 over 2 is just 0, so we can just rewrite that. This is just 1/2. This is root 2 over 2. This is root 3 over 2. And this is actually 1. Right? So, these are the nicer presentations of the numbers. But here, it's kind of neat that if you just remember those 5 angles and you can count from 0 to 4, then you can pretty easily get these. So how do we do cosine? Right? So to do cosine, once we know sine, we can actually get cosine really easily by just writing this backwards. The 1, root 3 over 2, root 2 over 2, 1 over 2, and 0. Right? It's the same values as sine, just backwards. Okay? And again, keep in mind these angles, they measure in the counterclockwise direction. So they start here on the positive x-axis, and the angles are always moving this way, so counterclockwise. If we move clockwise around the circle, we get negative values of theta, which are perfectly acceptable. We can use those. Just, keep in mind what the positive direction is here. Okay. So, what about this tangent thing? Right? If you don't remember or don't know, tangent theta, this is the ratio of the two sides here. So another way to look at sine and cosine, if we turn this line into a right triangle here, this length is sine theta, this length is cosine theta, and tangent is the ratio of these lengths. Right? Specifically, it's sine over cosine. Right? So now we just divide these things and we can figure it out. So here, 0 over 1, that's just 0. 1/2 over root 3, so we can just write 1 over root 3. Some of you guys might simplify that to square root of 3 over 3. Either way is fine. Here, root 2 over 2 divided by root 2 over 2 is going to just be 1. This one will just be square root 3. Now here we get something interesting. Right? When we try to do 1 over 0, that's not defined, right? So this one's actually undefined. Right? So this one, there's no actual number for that. Okay. So now that we have the basic values down, how do we get the rest of them? Well, once we get past pi over 2, right, pi over 2 is up top here. Once we get past that, the sine values are going to start going back down again. The cosine values are going to start going back up again in the same way they did over here, except sine is still positive, but now we're on the left half of the plane, so cosine's going to be negative. So, in quadrant 2, sine is positive, cosine is negative. Okay? So, once you know these values, we can sort of look at another sort of chart here, if you will. We can have sine, cosine, tangent, and let's duplicate that, duplicate it again, and one more time. So in each of the 4 quadrants, here everything is positive. Okay. In quadrant 2, sine is positive, cosine is negative, and therefore tangent will be negative. But these values are all still basically the same. We're going to measure sort of how far away from the x-axis we are. Right? This is both of those are negative, so tangent's positive again. And here, sine is negative, cosine is positive, so tangent's. Right? So kind of putting all that together, we can figure out any of the values. So if you had something like sine of 120 degrees, well, 120 degrees would be sort of up here. So that's kind of 60 degrees away from the x-axis, which would mean that we take the value for sine of 60 degrees, and here sine is positive, so sine of 120 degrees would be root 3 over 2. On the other hand, if we took cosine of 120 degrees, well, so we would still be looking at cosine of 60 degrees, except now we know cosine has to be negative, so it would be negative 1/2. Right? We just use this value right here, but remember cosine is negative. So if we put all that kind of stuff together, and think about the fact that we can keep letting theta get bigger and bigger all we want, and we're just going to keep winding round and round this circle. if we want to look at the graphs of these, just a quick sketch here for you. So the largest value they ever take on is 1. The smallest is -1. So it's not a very tall function. I'm going to put 1 here and -1 here. And let's make this 2 pi, so that this is pi. And then these are pi over 2, 3 pi over 2. Let's do the same thing over here. Try to make it as even as I can. And so if we go in the negative direction, we can get some stuff. So sine so this here, this is kind of the theta axis, if you will. Right? So when we plug in 0, we get 0. When we plug in pi over 2, we get 1, 0, 1, 0. And if we start plugging in stuff in between, we can get a few other values. So like if this is 1/2 and -1/2, let's see, sine of pi over 6 is 1/2. So that's somewhere about here. Right? 5 pi over 6 will be 1/2. 7 pi over 6 will be down here. Right, we can start seeing the shape of sine. Sine goes up, and then comes down, goes negative, then comes back up. A little bit of a shaky drawing, but... Oops. And then we can draw it in the other way as well. So sine just repeats this pattern over and over. Or, I guess the way I drew this here. We'll call this y equals sine of theta. Y-axis. Right, so that would be the graph of sine. Right? If we do this similarly, we can make a graph of cosine. Right? I'm going to make this one a little simpler here. This is 2 pi, and this one's pi. Right? If we apply the same reasoning to this, we can end up sketching ourselves a graph of cosine. Right? Graph of cosine will start up here at 1, and then it'll come down, go down to -1, and then make its way back up. And likewise, we'll do it over here too. So, we end up with, oops, rough sketch, but it would be our y equals cosine theta graph. Okay, so now you might wonder, well, what about tangent? Tangent's a little bit weird, but still completely doable. Now I'll let you think about these, all right? Think about, how you get the values of sine and cosine, and then think about how you get your tangent values. This one is going to work in a pretty interesting way. So let me say for tangent, let's just go from -pi to pi. Yeah, that'll be fine. All right, so this is -pi over 2 to pi over 2. So remember, tangent of pi over 2 doesn't exist. So we get what's called an asymptote there. Same here at -pi over 2. This cosine will again be 0. And then the way this graph is going to look is, if you remember, it starts at 0 and then it just keeps getting larger and larger. Oops. A little more flat than that. No. And it starts going negative in this direction. right? And then just like sine and cosine, since we're going round and round a circle, this graph's just going to repeat. It's what we call periodic. So you basically just copy and paste this picture as you go along. So we're going to get something like this. And like this. Right, you just keep seeing this little snake dude here, just paste it over and over and over. Right? And this is tangent theta. Right? So I'll leave you here with this. This is a very, very brief rundown of these. We'll talk a little bit more about them, but we're not going to focus too much on them in this class. But you'll use them quite a bit in the next semester. So just want to give you a heads up about it. Have a good one.